Before we start the next lesson, let us do a quick recap of what we have seen. So we saw that in procedural level programming, we have the focus is on the code or the action rather than on data. Whereas in object-oriented programming, the focus is more on the data. And why is this important? This is important because in procedural level programming, we can have issues if we have large and complex tasks, that is multiple tasks working on large amounts of data. So the data may get corrupted, or data may get unintentionally or altered. So we have to go for object-oriented programming. And another reason why we go for object-oriented programming is because it is the natural choice. It is because it becomes the natural choice as we tend to think in terms of objects in real life. So with this, let us move on to the basic 4 pillars of object-oriented concepts. So to understand object-oriented concepts, we have to learn 4 basic structures of this OOP. So what are these? The first thing is encapsulation. So I have already talked about an object. So we have an object. So what is an object? An object is nothing but the data and the code working on this data put together as one single unit. So these data, we call them attributes, and this code or the actions, we call them methods. So data will describe the object, whereas code will tell us what actions the object can perform. So this putting together of the data and the code as a single unit or a single entity, this is known as your encapsulation. This is your encapsulation. All right. So what is encapsulation? Encapsulation is the process by which we represent an object as a collection of data and code, where the code works on the data that is put together. So this is known as your encapsulation. So this is the first pillar or the foundation of an object-oriented concepts. The second term or the second pillar is that of abstraction. Now, so like you have again the mobile phone in your hand or a laptop in front of you, okay? Now, each of these systems are made up of more complex systems, internal systems, which we are not aware of, okay? We are not worried about the communications module that is there inside the mobile. We are not worried about how when you make a call, what happens internally, okay? All you know is that you have a button which you press, you select a phone number or you dial a phone number and the call gets made. Similarly, in the computer, you press a button and the system starts. So the internal workings, which are complex, are hidden from you. And what you get is only a simple interface through which you can interact with the more complex systems. You can take the same example of a car. A car, okay, consists of, again, multiple different systems. The braking system, the engine, the motor, the fuel transmission system, okay? But as a driver, you only need to know how to drive, how to apply the brake, how to start the car, okay? You don't need to know the internal workings. So this is nothing but abstraction. So in object-oriented programming, okay, we have an object. So if this is an object, we have an object, and then certain features, certain actions, all these are hidden. These are hidden from the outside. So hidden, these are hidden. And what is given is, again, some only few interfaces are given which are available for everybody to use. So internally, these, the ones which are outside can interact with the ones which are hidden. Okay. But for the user which is here, for a user, okay, the user can only interact with the ones which are available, with the interface which is available. Okay, so this is what we mean by abstraction. So this is the second pillar of object-oriented concept. Let's move to the third. The third is something, again, you must have seen earlier, that is inheritance. So what is inheritance? Inheritance means that you have an object. Okay, let's talk about a car. Okay, so you have a car. Now there are different types of cars. You may have a hatchback. You may have, let's say you have a, so we are talking about cars. So you have a car. Let me use a different color. So I have a car. Now a car can be a hatchback. Okay, it can be a sedan, or it can be a SUV, let's say. Okay. Now, a car can be described by certain things like its make, its model, its color, and so on. Okay. Now, all of these, whether it's a hatchback or a sedan or a SUV, okay, they inherit some common features from the car. Okay, they have some features which is there in all the cars, but also there can be some features which are available only in a hatchback, or only in a sedan, or only in a SUV. So instead of repeating whatever is here in a car, whatever is common, instead of repeating every time in each of these, okay, we may have something like an inheritance where the hatchback, the sedan, and the SUV will inherit from the car. So as a result, what happens? You have the concept of, or you have the advantage of code reusability. You can reuse the code which you've already written for car, and you can use it for all different class, all the other code, all the other objects. So inheritance plays an important role in object-oriented programming. And the last but not the least concept is polymorphism. So what is this polymorphism? So polymorphism, the word poly means many, and morph means form. Morph means form. So polymorphism means many forms. So let's say when you have something like, you are talking about starting a car, all right? Now you may have different ways in which the car can be started in case of a hatchback, in case of a SUV, or in case of a sedan. Okay, some may have a you have to turn a key. In some, you may have a button, press the button and the car starts. And maybe in an SUV, you may even have a say a voice activated start. Okay, so the starting mechanisms may be different, but the process is the same, start. Okay, so polymorphism is this particular concept where the same function can take multiple forms depending upon who is using it. Okay, so if I have in car, I have something called start. Okay, all of these, whether it's a hatchback or a sedan or a SUV, all of these needs to start, but the way in which it starts may be different. The way in which you can start these cars may be different. So, but when you say start, it should apply to all of this. So the start function or the start method can work differently for different cars. Okay, so this is your polymorphism. So do not worry if you don't understand much right now, okay, because as we go ahead, we will see all of these in action. So just to recap, so we saw the 4 pillars of object-oriented programming is your encapsulation, abstraction, inheritance, and polymorphism. So EAIP. These are the 4 pillars of your object-oriented concepts.